Hey, this is Chris with Hi-Lux Optics. Today we're going to be developing a new 308 Winchester load for our M1A. The last couple of sessions that we've had out at the range with the M1A, we've noticed some extraction issues, specifically some failures to extract the brass from the throat. When we look at the brass that we've shot, we've noticed a lot of extractor marks along the rims, and I think I was talking to some of my buddies, Bill Mitchell specifically, and he recommended us using a small base die. The M1A has particularly violent extraction, and with the desert dust environments that we shoot in, it could interfere with the extraction. So maybe sizing the base a little bit smaller with a small base die could help us with the extraction issues. So because of that, we're going to also develop a new load and kind of work something out specifically for our gun. The process I use for reloading may not be the same as everyone, but what I like to do is I first like to tumble my brass, then I'll size my brass. Or first off, I like to shoot the cartridge, get the brass, then I'll decap it using a hand deprimer. I don't like to run dirty brass through my press. I like to keep it nice and clean. So I'll decap it at the range, then I'll tumble it, then I'll full length size it, and then I'll trim it. And then after that, I'm thinking, this is my first time working with a small base die. I've heard it could also stick in the die body. So I'm gonna full length size it first, and then I'll run it through the small base die after trimming. Then I'll prime, charge the case, seat them, and then we'll do some load testing at the range. To keep some of the variables consistent, I'm going to load the length of my cartridge to full mag length, which is about 2.8 inches. We'll keep that variable consistent for now, and then we'll maybe once we do the charge weight testing, we'll go back and revisit what's the optimal seating or the length for our cartridge for our rifle. So once we control that variable. Also, we'll be using 4064. So 308 works, a lot of powders work great with 308. Varget, 4064, 4895. I'm just going to use 4064 because I have a lot of that, and I found a good load with it in the past. So I'm going to test my luck and see how that goes. Well, we'll take you through the journey of a single cartridge. So this is a cartridge that has been shot at the range. We just decapped it. Now, what'll happen next is we'll toss this into the tumbler. I use a Frankfurt Arsenal rotary tumbler with stainless steel pins. Typically, I like to put about a teaspoon of Dawn and a little bit of a lemon shine to keep the brass nice and shiny. And I'll tumble that for 2 hours. I usually put in around 100 to 200 brass. One thing to note is if you tumble them for too long, it is possible to ding the necks. Especially with the longer straight-walled cartridges. I have had this with 4570. Tumbling it for too long, you'll notice that the necks will get compressed and dinged up. So I'd say an hour and a half, 2 hours is the perfect amount of time. Once we have tumbled it, the next step is the full-length size. So make sure you use a good quality case lube. If you don't have a case lube, what I like to do is I learned this from my mentor Leo, and he told me to mix in 10 parts of rubbing alcohol. The stronger the better, so 90% if you can get it, 10 parts of that, so 1 part of lanolin, and that works pretty well as a case lube. And I have it already pre-mixed. I have it in a little spray bottle, and what I'll do is once I have the clean brass from the tumbler, once it's dried, I'll spray some of this on, let it soak in there, and then I'll start running the full-length sizing die. Once you've cleaned your brass, the next step is the full-length size. So I'll grab my full-length sizing die, and I'll set that up on my press. So I'll drop the handle, I'll screw in my brass, or I'll screw in my die, and I'll just touch off the die to the end of the brass holder, and then I'll maybe add 1/8 of a turn. So what I'm doing by turning it a little bit extra is to make sure that the full length sizing pin or the decapper pin is sizing the entire piece of brass. So normally I'll have however many pieces of brass in a tub, and I'll spray it with some lanolin. I have this mixed 10 parts to 1 lanolin or 10 parts of rubbing alcohol, 90% to 1 part of lanolin. So make sure you give it some time for the lanolin or the lube to dissolve or work its way in. If it's wet and you're sizing it immediately, you run the risk of, I'm not sure why this happens, but the brass will get compressed and will have a little bulge in it. All right, so this piece of brass has been lubed, and we'll full length size it. All right, so the next process is to trim our brass. We can look at our reloading manual, and I'm using the Lyman 50th edition loading manual, and turn open to the 308 Winchester page. So if you open it up there and go to test components, or under that column, you'll notice a trim to length. So it's listing the minimum SAMI trim to length, which is 2 inches and 5/1000ths. And the specific trim length will depend on your processes and your preferences. So now there's a lot of discourse about this, and personally, I like to do all the processes every single time so that I'm consistent. And because of that, I don't want to trim too much off of my brass. There is a maximum amount of life that you can get out of a piece of brass, and the more work you do to it, the more you're taking away from that piece of brass's life. So what I like to do is I like to trim to the maximum length, which is 2 inches and 15/1000ths, and I'll just do that every time, just so I know that every piece of brass is consistent. So this I trimmed with the Giro power trimmer, and it does 3 processes in one, 3 operations in one. It'll trim to your length, it'll deburr, and it'll chamfer. So once we've done that, we can check with the caliper and see that our overall length for the brass is pretty much spot on. So I'm at 2 inches and 14/1000ths, 5/10ths. So pretty much spot on. So the next step for this is to small base size this. So I've actually run this through a full length sizer first, and I've talked to the guys at Reading, and they actually recommended to full length size it first, then run the small base, just because there's a chance that because of how aggressively you're sizing the bottom of the case, there's a chance for it to get stuck. So they recommended using a lot of good quality case lube and to full length size it first, so it doesn't have to do as much in the second operation. So I'll get my small base sizing guide on this. And I'll get this set up in the same way that I do my full-length dies. So I'll just run the die all the way down until it touches this rod right here. Okay. And then I'll do an 1/8 of a turn extra. Ooh, that might be too much. There we go, that feels pretty good. Okay, so I've already got a bag of brass that I've already full length sized and also trimmed. If you want to get crazy, which I don't really want to do right now, you could weigh every single piece of brass and then sort your brass by 1 grain or even half grain increments. For me, I think, at least for this first test, I don't think it's that critical. So I'm just going to pull 100 pieces of brass out of here. All right, that should be pretty close. This is about, let's say 100 pieces. I'll hit it with some of my lanolin rubbing alcohol case lube. let that work its way in. I'm kind of lazy. I just spray everything in a bucket. You could spray this onto a pad and rub it on, and also work the insides of the necks, just so you make sure you get the lube more consistently. But I've found that this works pretty well. All right, we'll give it a sec for the lube the alcohol to dissolve. All right, I think we're good to go. So. It's a little bit tight. And there we go. To prime the brass. I like to use a hand primer. There's a bunch of different ways you can do it. You can have an accessory with your single stage press, a little tube that'll get the primers into place, and you can prime them on the press. I find that hand priming them, I get pretty decent consistency, and it's a lot faster for me. So I'll load up this tray with some more primers. All right, so we put the primers in the tray. Some of them are facing the wrong way, but if you just kind of wiggle it back and forth a little bit, you'll notice that all the primers will be facing the right way. This is a spent primer. All right, so let's get the cap or the lid back on it. So if you are using a little hand primer, make sure that the bottom of the primer is facing up. You want the surface that the firing pin strikes to be facing down. So we'll do these one at a time. I like to use these trays to stage all my brass in the different stages. Okay, so. And you want to visually confirm, and you can also check with your finger that the primer is seated about 3 thousandths past the rim of the brass. So this looks good to me, and I'm just going to try to find consistent hand pressure. So when you're using the hand primer, you want to make sure that before you prime the next piece of brass, that the primer is sitting properly in the hole. You don't want them to be two in there or double up, or it would be a bad day if one of these exploded in your hand. I don't really like to watch TV or do anything like that, or even have music going on. I like to focus on this. I take pride in my reloads, and if I'm going to go through and have the time or spend the time to reload, I want to make sure everything's consistent, and I don't have any mental lapses. So like no double charges, nothing wrong with the primers. I want to make sure everything is done to the best of my ability. So I like to be focused, and for that reason I don't really load more than 200 rounds in a sitting. Other than that, it could get a little bit boring, or maybe your mind starts to wander, but if that's the case, I'll break it up into sections. Maybe I'll just tumble full length size, and then do the trimming, and then I'll label the brass or the brass for whatever stage it's at, how many times it's been fired, the date, and then go from there. I'll maybe pick it up from another date down the line. And that's another good point. So note keeping. I like to keep a little notebook with my load data. This way, it's like a scientific process. So we're trying to figure out the best load and I like to keep all the data, as much data as possible, so that I can refer to it down the line. Yeah, you may think that you may say, oh, I write it down and I'll refer to it on my phone, but I like having something physical that I can look at, and I'll keep it with all my reloading components. If I'm reloading and a recipe or a load worked out really, really well, I'll star it, and then next time I'm doing another reload, and I have something that I can reference quickly. All right, just getting about finished with the priming. Hold on, I'm noticing this is a little, set that one aside. I noticed that this piece of brass over here has a little, the chamfer is not good all the way across, so maybe I'll full length size another one to replace that. Yeah, that's another benefit of doing everything on a single stage, because it takes longer, you spend more time, and that's quality control right there. All right. Yeah, if I were loading this for like a F-class gun or like a competition rifle, I might go through the time and sort all the brass and all the components too, like the projectiles by weight. At least for this, we're just doing our initial charge weight test. I don't think it's going to be that critical. I know all the brass is within 3 grains, which is pretty standard for a lot of factory for brass out of a single lot. So every lot you can expect. I mean, a lot of the companies, Federal, Starline, they say that all their brass is in the same lot is within 3 grains, and I find that to be an underestimation. In the worst case, it's probably an extreme deviation of 3 grains, but for the most part, it's probably within 2 or less. If you have Lapua or you use Peterson or some other high-end brass, you'll probably find that your brass is within 1 grain, and that's fantastic. That saves you the time. You don't have to necessarily go through and sort them. But if you're just using regular factory ammo that and you're reloading it, and you'll probably find that your brass has an extreme deviation of 3 grains. If you go through the extra time and sort the brass, you'll probably get better or more consistent reloads. So let me just replace this. All right. Now that we've primed all our brass, the next step is to charge our brass with powder. And for 308, there's a lot of powders that work well. I'm going to use 4064. That's worked well for me for my loads in the past, and frankly I have a lot of it, so I'm going to use it up. But what I would recommend you do is see whatever bullet projectile you're using. I'm using the Sierra 150 grain hollow point bow tails, number 2190, and this Lyman manual doesn't actually have a specific load recommendation for that. So what I did is I went to the Sierra website and I found out some reloading data that they had on their website, and I printed it out. So 2190 right here, 308 150 grain hollow point boat tail match, and we'll go down the column and we'll find IMR 4064, which is what we're using. And the first load that they recommend starting at is 41.2. So we'll start there. They say the maximum recommended charge weight is 46.8. So when you're working up your charge weight, I like to start off from whatever the 10% off of the maximum load maximum recommended charge weight is, and I'll work my way up in maybe half grain increments. So in this case, the first one they say is 41.2. We'll start off at 41. We'll go 41.5, 42, 42.5, 43, and so forth until we've reached the maximum recommended charge weight, which in our case for 4064 is 46.8. From my experience, I've found that there's two nodes that work pretty well. One, the high node, close to the maximum charge weight, and there's also a lower node. If you shoot the high node, your velocities will be a lot faster, and you may also wear out the throat of your barrel faster. For this case, I'm probably gonna just work out a load try to find the low node. I should probably be around 25 to 26, probably 2,600 feet per second. And for me, for this load, I'd be very happy to shoot out to 600 yards consistently. So I think that'll work out for me. And let's get started. So we're doing a ladder test. We're going to be starting off with 41 grains. We'll do 41, 41.5, 42, 42.5, 43, 43.5, 44, 44.5, 45, and 45.5. And hopefully somewhere in there, we'll find a charge weight that works well with this bullet. And as far as the length of the cartridge, I'm going to keep it consistent. I'm going to load it to mag length, which is about 2.8 or 2 inches, 800 thousandths. We'll find our optimal charge weight first, and then we'll vary the overall length to see what this gun likes. So let's get started. And I also recommend having a notebook for each of your rifles that when you're reloading. That way you can refer to the specific load that worked particularly well. Since this is the first load that I'm developing for this is a new notebook, so I'm going to write, I'll have today's date, which is the 29th. And it's a 150 grain hollow point boat tail from Sierra, specifically bullet Projectile 2190. And I'm going to write the lot number. The lot number is, or the product number is actually over here. So you'll see these are two consecutive boxes of the same projectiles from Sierra, and these have sequential, I guess, product numbers or lot numbers. So I'm going to take note of this. Couldn't hurt to write more data. If I don't load it, there's 100 projectiles in this box, so I'll be able to refer to that next time I reload. So you could use a notebook, or you could also use your cell phone to write this down, whatever works for you. Personally, I like something physical that I can refer to. And also, I'll keep this with my reloading bench with my rifle. So it's just something physical, tactile that I can hold and reference. Same reason why I like reading physical copies or have physical copies of books. I could get this on the iPad, but I like flipping through and touching something physical. I don't know. It could be weird, but that's me. But yeah, I'll take notes. Detailed notes on everything. All right, so I was doing a little bit of thinking, and I think instead of doing half grain jumps, I'm gonna go 3/10. And the reasoning is, to be quite frank, we're kind of far from the range, and I don't want to have to do another charge weight test. I'm thinking if I go in every 3/10 increments, and I really only care about the low node starting from 41 grains, so anything above 25-50 feet per second I'll be happy with if we can find a node that works well. So that way we can just go a little bit finer on the charge weight testing and see if we can find that low node and find the optimal weight for charge weight. So we'll keep the same initial charge weight of 41 grains, but instead of going to 41.5 and 41.2, we'll go in 3/10 increments, so to 41.3, 41.6, and so forth. I'm just going to make a note on my reloading notes right here. And there really is no set in stone rule. You could go. I usually go 0.5 when I'm trying to in my first time reloading or developing a load, just to find where the nodes are. But in this case, I don't really want to find that high node. I'm content with something at least 2,600 feet per second. So we'll go a little bit finer. Okay, so next step, now that we have our different charge weights, we'll pour in the powder in the auto trickler, and we'll load or charge up those cases. So we got our auto trickler right here. I'm gonna fill it up with the 4064, the IMR 4064. Okay, so I'm using the A&D FX 120 lab scale. This one is doesn't really have that much drift. If you're using something like the RCBS, I've actually found that throughout the time I'm charging the cases, I've noticed that the weight on the scale kind of drifts a little bit. So if you're using one of these, I'd recommend to turn it on for like 15-20 minutes, let it warm up, and then use it. I've already calibrated this with the calibration weight. I'll zero this out, and then I'll connect it to the app. Okay, so we'll be loading five cases for each of the charge weights. Each row will be a different charge weight, and we'll start off with 41 grains. So I'm gonna connect. You can play around with the settings on the auto trickler. So like the buffer weight between switching between the big tube and the small tube. And you can try to get it to go a little bit quicker. I've kind of got it figured out, but I'm still working out the settings. Honestly, out of all the processes in reloading, this is probably my least favorite. It just takes time, and there's no way around it, and you got to be extremely precise with this part. So definitely take your time. Make sure that you don't overcharge or undercharge. The whole point of doing load development is to be precise with every step, and we want to make sure we're getting exactly, or sorry, for this case, we want 41 grains plus or minus 200ths. So we want to make sure every load is within those parameters. We've done all the charges for our charge weight testing. Now we got to seat the bullet. So there's a couple ways to do this. The most precise way is to seat off of the ogive of your projectile. I'm just gonna eyeball it and use the caliper from the base to the tip of the bullet. So the tip of the bullet could have some variation, but I'm gonna aim for an overall length of just under 2.8 so that I can fit in my magazine. Okay, so let me open up these projectiles. So one thing to note, I'm using the RCBS seating die. Right. This does two operations. It'll seat the bullet, and also at a certain depth it'll crimp the bullet too. So I definitely want to crimp, but I like doing this in two stages. I don't like doing both the seating and the crimping at the same time. So I'll start with this backed out quite a ways, and then I'll work my way in, and then I'll adjust the top seating stem to make sure I'm at the right seating length first. So got this bullet started. It's at about 2.847 plus or minus a couple thou, just because the tip could have some variation. All right, let me grab a tool. All right, we're getting close. So I'm at 2 inches and 810 thousandths. Okay, 2.795. That's pretty much where we want to be. I'm going to try another bullet or another projectile, and then we'll just verify and confirm. Yep, so we're within a thou. I have the seat length pretty much set. I'll go through and I'll seat all these projectiles, and then I'll go through and I'll crimp them. But one thing that I'll make sure I do is I'll back out the seating stem, because I'll need to adjust the body of the die, and that'll also change the length or the depth that we seat the bullets at or the projectiles at. I'll need to back it out so we don't mess with the seating or the length. So I'll get through all these projectiles. Yeah, and the nice thing about doing everything on a single stage is, like I said, the quality control. You can double check your work every time. It just takes a couple seconds longer, but you'll make sure, you'll ensure that you'll have more consistent, better ammo. Yep, right there.